Beautiful online classes. In the last class, we discussed some of the basics regarding the Newton's laws, that is a momentum, change in momentum. How can we calculate the change in momentum? Change in momentum is always taken as final momentum minus initial momentum. And we discussed a different 4 cases, that is whenever the ball will be striking the vertical wall. In case 1, the ball will be coming to the rest. In the case 2, the ball will be rebounds with the velocity, same velocity v. And in the third case, with the different velocities we taken. And in the case 4, the ball will be striking the wall by making an angle theta with respect to the normal. Now, today we are going to discuss the change in momentum in different cases. In that, the first case is about projectile motion. So, in the projectile motion, we derived the expression for the trajectory of the projectile, that the value is equal to y is equal to ax minus bx square you derived in the theory. But here, where we have to calculate the change in momentum, in between which points we are going to calculate the change in momentum in the case of the projectile. So, in the case 1, so we are going to calculate the change in momentum value in between the highest point to the point of projection. Between which points we are going to calculate? Between highest point and point of projection. So, between these 2 points we are going to calculate the change in momentum value. To calculate the change in momentum, you must know what is the initial momentum of the projectile and what is the final momentum of the projectile at the highest point. So, as the body will be projected with the initial velocity u, we resolve the velocity into 2 components. One is u cos theta along the horizontal direction and u sin theta along the vertical direction. So that the initial velocity vector is u bar is equal to, we will write u cos theta into I cap plus u sin theta into j cap. So, in the case of the projectile motion, if a body will be projected with the initial velocity u, its initial velocity vector will be written as u cos theta I cap plus u sin theta j cap. If we assume the mass of the given projected body is equal to small m, so the initial momentum of the projectile will be given by m into u bar. Its value is equal to mu cos theta I cap plus mu sin theta j cap. So, this is the expression for the initial momentum of the projectile at the point of the projection. So, what is the initial velocity vector here? U bar is equal to u cos theta into I cap plus u sin theta into j cap. So, we assume the mass of the given body is equal to small m, so that the initial momentum vector can be written as mu cos theta I cap plus mu sin theta j cap. Now, I want to calculate the momentum value at highest point. The momentum value at the highest point. So, already you know that in the case of the projectile motion, at the highest point, the velocity will be given by u cos theta only. So, there is no vertical component of the velocity at the highest point, so that only horizontal component of velocity will be existed at the highest point. So, that the velocity vector at the highest point will be given by u cos theta into I cap. So, it is representing velocity present at the highest point. So, that the final momentum value is equal to mu cos theta into I cap. So, this is the equation number 2. Final momentum is equal to what? Mass into velocity. Velocity value already you know at the highest point. So, that the final momentum is equal to what? Mu cos theta I cap. Change in momentum delta p bar is equal to pf bar minus pi bar. So, final momentum minus initial momentum. What is the final momentum value here? The final momentum value is equal to mu cos theta I cap minus initial momentum value is equal to what? Mu cos theta I cap plus mu sin theta j cap. Simply you substitute the values of initial momentum, that is mu cos theta I cap plus mu sin theta j cap. Here cos theta components will be getting cancelled. Therefore, the final momentum The final momentum will be getting cancelled. The change in momentum value is equal to only you have minus mu sin theta j cap, minus mu sin theta j cap. So this is the expression for change in momentum in between the highest point and point of the projection, Here in the case 2 where we are going to calculate the change in momentum value means, in the case 2 we are going to calculate the change in momentum between the points A and O. What is the A here? The point at which the projectile will be landing on the ground. The point at which the projectile will be landing on the ground or hits the ground, and O is called what? Point of projection. So already we know that to calculate the change in momentum value, you have to know the initial momentum value as well as the final momentum value. Already you know that the initial momentum of the projectile will be given by mu cos theta I cap plus mu sin theta j cap. Let it be equation number 1. Now we have to discuss what is the velocity of the projectile at the point A where it was reaching onto the ground. Already in the theory we told that along the horizontal direction there is no acceleration was present, hence the horizontal component of velocity is always to be constant, that is ux. What is the ux? Ux is indicating the initial component of the velocity along the x-axis. Ux value is equal to Vx, that value is equal to u cos theta. That horizontal component of velocity will be remain same. Now, in the case of the motion in one dimension, one special case is there. If any one of the body will be thrown vertically upwards with an initial velocity u, while it was returning to the ground, while it is reaching the same point, the magnitude of the velocity will be remain same. So if any one of the body was projected vertically upwards, with some initial velocity u, while it was reaching onto the ground, its the final velocity will be represented by v bar is equal to minus u bar. V bar is equal to what? Minus u bar. What it denotes means the magnitude of the velocity while it was reaching to the point of projection will be remain same, but its direction was reverse. Similarly, whenever the projectile will be reaching onto the ground, the vertical component of the velocity will be acting in the downward direction, but its magnitude value does not be changes. So that the vertical component of the velocity is equal to what? U sin theta, but when you consider the vector notation, a negative sign will be coming. So that finally, how can we write the final velocity of the projectile on reaching to the ground? The velocity of the projectile on reaching to the ground is, so I am taking the final velocity will be as a v bar. Horizontal component of velocity does not be changes, so that horizontal component of velocity will be remain same, but the vertical component of velocity magnitude will be same, but its direction was reversed, so that v bar is equal to u cos theta I cap minus u sin theta j cap. So v bar will be giving the final expression for the velocity of the projectile while it was reaching on to the point A. So that the corresponding final momentum will be given by, this is a velocity. If you want to the momentum, simply we have multiply with the mass. So that the final momentum value is equal to mu cos theta I cap minus mu sin theta j cap. Equation number 4. So these are the expressions for the initial momentum as well as the final momentum. So that to find the change in momentum, so the general formula is delta p bar is equal to pf bar minus pi bar. What is the pf bar? So pf bar value is equal to mu cos theta I cap minus mu sin theta j cap minus of pi value mu cos theta I cap plus mu sin theta j cap, mu sin theta j cap. So here mu cos theta I cap positive value minus mu cos theta I cap is the negative value. So these two will be getting cancelled. So finally you are getting the change in momentum value is equal to minus 2 mu sin theta into I cap, minus 2 mu sin theta into j cap. So this is the expression for change in momentum of a projectile at the point A while it was hitting the ground. So this is the change in momentum in the case of the projectile motion. Next concept is a very important one. We are going to calculate the change in momentum value, in the case of the uniform circular motion. Uniform circular motion. What is the meaning of the uniform circular motion? If any one of the object will be revolving in the uniform circular motion, the magnitude of the velocity is a constant. The magnitude of velocity will be constant at each and every point along the circular path. Only its direction will be changes from point to point. Even though its direction will be changes, simply we will say that the velocity will be changes. Velocity is a vector quantity. Either the magnitude will be changes or the direction will be changes. Finally, we will say that the vector quantity will be changes. So here I consider that a particle will be revolving along the circular path, and I am assuming that at a given instant the particle will be initially at the point A. So to know the direction of the velocity or the direction of the momentum, simply we draw the tangent at a particular point. That tangent will be giving the direction of the velocity. Whatever the tangent you drawn at any point along the circumference of the circular path, that tangent will be giving the direction of the velocity or direction of the momentum. So here we assumed that the speed of the revolving particle will be remains a constant. If the speed of the revolving particle will be remains a constant, the linear momentum magnitude will be constant. So the linear momentum value P is equal to mv, whose magnitude will be constant. But when you are discussing the momentum as a vector quantity, the momentum vector quantity will be changes with respect to the direction. So here we are assuming that at the point A, the particle will be having the initial momentum value. At the point P, at the point B, the particle will be having the final momentum value. So what is the expression for change in momentum value? Final momentum minus initial momentum. Final momentum minus initial momentum. Yesterday I told, to calculate the magnitude of the change in momentum, we must took the mod on both sides. So when you write modulus of delta p bar, means that the modulus of delta p bar is indicating the magnitude of the change in momentum. So the general expression for the modulus of pf bar minus pi bar is equal to pi square plus pf square minus 2pi pf into cos theta. So yesterday also we wrote the same formula. According to the vector subtraction, we are calculating the magnitude of the change in momentum. So pi square plus pf square, pi pf cos theta. Here pi square comma pf square are indicating the magnitudes only. So here already we assumed that the magnitude of the momentum will be constant, so that I am taking pi is equal to pf is equal to mv. Okay, so here we will write mv whole square plus mv whole square minus 2mv mv into cos theta. So here in the place of either pi or pf, we will write the value of mv, and if you simplify this equation, so finally you are getting that 2mv sin theta by 2. 2mv sin theta by 2. So this is the expression for change in momentum of a particle, while it is revolving in the uniform circular motion, So these are the different applications for calculating the change in momentum. is we are going to discuss about law of conservation of linear momentum. Before going to discuss this law of conservation of linear momentum, what is the Newton's second law? The Newton's second law states that the force is equal to the rate of change of linear momentum. So already we know the formula for the force is what? F is equal to dp by dt. The rate of change of linear momentum will be equal to the external force acting on a given system. So, according to the law of conservation of linear momentum, if there is no external forces acting on the given system, the total linear momentum of the system is equal to constant. Once again, what is the statement of the law of conservation of linear momentum means? According to the Newton's second law, you know the formula F is equal to what? dp by dt. Equation number 1 I taken. So, whenever there is no external forces acting on the system, then the total linear momentum of the given system will be constant. Such a type of law we are calling as law of conservation of linear momentum. So, according to the law of conservation of linear momentum, if F external is equal to 0, so this dp by dt value also is equal to 0. What? 0. So when we will say a derivative of a physical quantity will be is equal to 0, whenever that a physical quantity will be either the maximum value or minimum value, then only its derivative will be is equal to what? 0. If dp by dt value is equal to 0, we will write P is equal to constant. P is equal to what? Constant. What is the P indicates? P is indicating the linear momentum. So, already we know the formula. P is equal to mv, which is equal to constant, or we will write m1 v1 is equal to m2 v2. So, this equation will be tells the law of conservation of linear momentum. So, what is the law of conservation of linear momentum? Whenever there is no external forces acting on the system, the total linear momentum of the system must be a constant. Now, we are going to discuss the applications of the law of conservation of linear momentum. In that, the first application is recoil of a gun. The first application is what? Recoil of a gun. So, here in generally we consider a gun bullet system. A system means what? A system is including 2 or more number of masses or 2 or more number of particles. So, here what system I consider here? I consider a gun bullet system will be considered. So, which is indicating the gun, and inside the gun I assume that one bullet will be there. So, before we are firing, the state of the gun bullet system will be in the state of the rest. So, whenever initially the state of the system will be in the state of the rest, so initial velocity is equal to 0. If initial velocity is equal to 0 means what? Initial momentum also is equal to 0. Initial momentum is equal to what? 0. If initial momentum is equal to 0, according to the law of conservation of linear momentum, the final momentum must be equal to 0. Once again, so what we consider here? Gun bullet system will be considered. What I assumed here? The gun and the bullet system both are initially in the state of the rest. If the system is initially in the state of the rest, its initial velocity is equal to 0. If there is no initial velocity, initial momentum also is equal to 0. So, according to the law of conservation of linear momentum, if initial momentum value is equal to 0, then final momentum also equal to 0. If initial momentum value is equal to 0, final momentum also equal to 0. Now, we assumed that we fire the bullet and the bullet will be leaving the gun and it will be forwarding in the forward direction with a velocity of small v bar. So once the bullet will be leaving from the barrel of the gun, the bullet will be in the motion. The bullet will be in the motion. Once the bullet will be in the motion, it have some linear momentum. So the linear momentum of the bullet is equal to, I am writing m into v bar. M into v bar. So I am assuming that small m is indicating the mass of the bullet and the v bar is indicating what? Velocity of the bullet. So momentum means I took the vector quantity. Linear momentum of the bullet is equal to what? M into v bar. So whenever the bullet will be leaving in the forward direction, the gun will be moving in the backward direction. The gun will be moving in the backward direction. That is calling as recoil of the gun. What is the meaning of the recoil of the gun? Means what? While the bullet is leaving from the barrel in the forward direction, the gun itself moving in the backward direction to balancing the momentum of the bullet. To balancing the momentum of the bullet. That means the gun itself will be moving in the backward direction, means gun is also came into the motion. Gun is also came into the motion. That means the gun is also having some momentum. The gun is also having some momentum. The momentum of the gun will be taken as P suffix capital G bar. I am assuming that the mass of the gun is equal to capital M and the recoil velocity will be assuming as, the recoil velocity will be assuming as capital V bar, capital V bar. So from this statement, initially the total momentum value is equal to 0. Initially means before firing the bullet. Before firing the bullet, initial momentum is equal to 0. Once we fire the bullet is in the motion and the gun is also in the motion. That means finally, whatever the two objects will be there, both bullet as well as the gun, these two will be existed in the motion. So that the final momentum value is equal to, it is the sum of momentum of the bullet plus sum of the momentum of the gun, and whose total value is equal to 0. Whose total value is equal to what? 0. But according to our definition, our statement, the final momentum value is equal to 0. So that I equate the final momentum value to the 0. Now I want to calculate the recoil velocity of the gun. So that I am writing that the momentum of the gun is equal to minus of momentum of the bullet. From this equation, PB bar plus PG bar is equal to 0 means PG bar is equal to minus PB bar. So here, what is the momentum of the gun? Capital M into V bar. Capital M into V bar is equal to minus small m into small v bar. So I want to calculate the recoil velocity. The recoil velocity v bar is equal to minus small m into v bar by capital M. So which is giving the recoil velocity of the gun. The recoil velocity of the gun. So this is the next concept is common velocity. Common velocity. Here we are assuming that a wooden block having a mass of capital M, is initially in the state of the rest. So what we are assuming here, on the horizontal surface or over a table, we place a large wooden block whose mass is equal to capital M and which is initially in the state of the rest. If it is in the state of the rest, its initial velocity is equal to 0. I am assuming it is the second body, its initial velocity is equal to what? 0. So I will calculate its momentum value. Momentum is equal to mass into velocity. So its momentum will be taken as a P2. Mass is equal to capital M and its initial velocity value is equal to 0. So that the momentum of the wooden block is equal to 0. See once again, which type of object we consider? Wooden block is considered. That wooden block is placed on the horizontal surface and which is initially in the state of the rest. Whenever any one of the object will be initially in the state of the rest, its initial velocity is equal to 0 and I calculated its momentum value. Initial momentum is equal to what? 0. Now, onto the wooden target, I fired a bullet which is traveling with a velocity of small v. So initially one target will be there, that a target mass is equal to capital M. Onto the target we fire a bullet whose mass is equal to small m and its velocity is equal to small v. So what I assumed that whenever the bullet will be reaches the target, it is embedded into it, and after that these two will be moving together. What are the two? The bullet and the target itself, these two objects are moving together with a common velocity, If such type of a case will be there, you have to calculate the common velocity of the system, So for that, we calculated the initial momentum of the block. Now I want to calculate the initial momentum of the bullet. Initial momentum of the bullet is equal to what? M into V. Its mass is equal to M, velocity is equal to V. So the total initial momentum of the system, is equal to what? It is giving the sum of the momentum of the bullet and the momentum of the target, so that the momentum of the target value will be is equal to 0. So the initial momentum of the system is equal to M into V. The initial momentum of the system is equal to what? M into V. So this is the case 1, that is before the system will be came into the motion. Once the bullet will be penetrated, embedded into it, and if the bullet and target will be moving with a common velocity, its mass becomes to what? Its mass becomes to m plus m. M plus m. Why? Target will be there. In addition to the target, inside the target the bullet will be embedded, so that the total mass of the system becomes to what? M plus m, and they will be moving with a common velocity, that a common velocity represented by V suffix c. So that I have to calculate the final momentum of the system. In the final momentum of the system, what is the total mass was present here? M plus m. Total mass is equal to what? M plus m. And what is the velocity of the system? V suffix c. That is, both are moving with the common velocity. Let it be equation number 2. So here already we told that in the case of the law of conservation of linear momentum, total initial momentum is equal to what? Total final momentum. Total initial momentum is equal to what? Total final momentum. What is the total initial momentum value here? Small m into V. So initial momentum value is equal to what? M into V, and the final momentum value is equal to M plus M and V suffix c. So we equate the initial momentum value as well as final momentum value. Now I want the expression for the common velocity only. Therefore the required expression for common velocity is that is nothing but mv by m plus m, that is equal to what? mv by m plus m. So this is the expression for common velocity. So here also what we applied here, before the bullet will be striking and after the bullet will be striking, simply you have to calculate the total momentum value, and we equate initial momentum is equal to final momentum. Whatever the applications and numericals are came over this concept, simply first we have to calculate total initial momentum of the system and total final momentum of the system. Like in the collisions, you calculated total momentum before the collision, total momentum after the collision. There you apply law of conservation of linear momentum. Therefore you wrote total momentum before the collision is equal to total momentum after the collision. The same application we did here. So this is another application of law of conservation of. The next topic is explosion of the bomb. It is a very important topic. Here again two different cases are there. If the bomb will be explodes into 2 pieces and if the bomb will be exploded into 3 pieces. First we will assume the bomb will be explodes into 2 pieces. The given bomb will be explodes into 2 pieces. So here also we have to calculate initial momentum of the bomb before the explosion, and we have to calculate the final momentum of the two pieces after the explosion. So initially I am assuming that there was a bomb whose mass is equal to capital M. So what we are assuming here, I consider a bomb whose initial mass is equal to what? Capital M. And I am assuming that the given bomb is in the state of the rest. The given bomb is in the state of the rest. If the bomb will be in the state of the rest, its initial velocity is equal to 0. If its initial velocity is equal to 0, initial momentum also is equal to 0. So what we consider here? We consider a bomb and whose mass is equal to capital M, and what we assume here, the bomb itself will be in the state of the rest. If it is in the state of the rest, initial velocity is equal to 0. If initial velocity is equal to 0, initial momentum of the bomb also equal to what? 0. Now, I am assuming that the bomb will be explodes into two pieces. The bomb will be explodes into two pieces. If any one of the object will be explodes into two pieces, they must move in opposite directions. They must move in the opposite directions. I am assuming that the first piece of mass is equal to m1 and the second piece of mass is equal to m2, and its velocity is equal to v1 and its velocity is equal to what? v2. So because it was explodes into two different pieces, I assign the masses as well as the velocities. So here I want to calculate the momentum of the first piece. The momentum of the first piece. Let it be P1 bar. P1 bar is equal to what? M1 V1 bar. M1 V1 bar. And P2 bar is equal to M2 V2 bar. P2 bar is equal to what? M2 V2 bar. But here I am placing the negative sign. I am placing the negative sign. Why we are placing the negative sign? With respect to the first object, with respect to the first piece, the second piece will be moving in the opposite direction. That's why momentum is a vector quantity, so that we assign the negative sign. So the final momentum is equal to, how can we write? Sum of the individual momentums. So Pf bar is equal to what? P1 bar plus P2 bar. Substitute that values, M1 V1 bar minus M2 V2 bar. So this is the expression for the final momentum. Now, according to the law of conservation of linear momentum, what we know, initial momentum is equal to 0, then obviously final momentum also equal to what? 0. See, in the case of the initial stage, the momentum was in the momentum value will be is equal to 0, since the bomb is in the state of the rest. So that if initial momentum value is equal to 0, final momentum also equal to what? 0. Therefore, according to the law of conservation of linear momentum, we know that total initial momentum of the system is equal to total final momentum of the system. So, initial momentum of the system is equal to what? 0. Initial momentum of the system is equal to what? 0. And the final momentum of the system is equal to what? M1 V1 bar minus M2 V2 bar. So, if you simplify, if you take in terms of the magnitude, we will write M1 V1 is equal to M2 V2. M1 V1 is equal to what? M2 V2. Like this, we have to calculate either the momentum of the first piece or momentum of the second piece. So this is the case when the given bomb will be explodes into two pieces only. And now we are going to calculate, if the bomb will be explodes into three pieces, how can we calculate the momentum of the third piece? Now we are assuming that the given bomb will be explodes into three different pieces. The given bomb will be explodes into what? Three different pieces. So initially the bomb will be in the state of the rest and whose total mass is equal to m, so that initial momentum of the system is equal to what? 0. Initial momentum of the system is equal to what? 0. Now, after the explosion, we assume it is exploded into three different pieces. Its masses will be taken as m1, m2, m3, and its velocities will be taken as v1 bar, v2 bar, v3 bar respectively. So when the bomb will be explodes into three different pieces, here just we assign their masses as well as their velocity values. So we will write the final momentum of the system is equal to final momentum of the system is equal to final momentum of the system is equal to what? P1 bar plus P2 bar plus P3 bar. P1 bar plus P2 bar plus P3 bar. So let it be equation number 2. Equation number 2. So final momentum value expression is equal to what? P1 bar plus P2 bar plus P3 bar. Sum of the initial momentum of the momentum of the first particle, momentum of the second particle, and momentum of the third particle. So here already you know that initial momentum of the system is equal to 0. So if initial momentum of the system is equal to 0, final momentum of the system also is equal to 0. So therefore from the equation number 2 we will write P1 bar plus P2 bar plus P3 bar is equal to what? 0. So I want to calculate the momentum of the third piece. If you want the momentum of the first piece also, we will write. So the momentum of the third piece will be given by minus of P1 bar plus P2 bar. So like this we have to calculate the momentum of the third piece, whenever the bomb will be explodes into three different pieces. So if you want to know what is the direction of the P3, what is the direction of the P3 and how can we calculate its magnitude means. So here I am assuming that this is the direction of the momentum of the first piece. This is the direction of the momentum of the first piece. When the bomb will be explodes into three different pieces, they should not be moving in the opposite directions. They will be traveling in different directions. I am assuming that the first piece will be traveling in this direction and the second piece will be traveling in this particular direction. Here P3 bar is equal to minus of P1 bar plus P2 bar, meaning is what? So P3 bar will be in a direction, which is opposite to the sum of P1 bar plus P2 bar means the direction of the P3 bar will be opposite to the resultant of P1 comma P2 bar. So the direction of P3 bar is opposite to the direction of resultant of P1 bar and P2 bar. So that is the meaning of this equation. P3 bar is equal to minus of P1 bar plus P2 bar means what? The direction of the third piece will be in a direction which is opposite to the resultant of P1 bar comma P2 bar respectively. Whenever two vectors will be acting at a given angle, so the resultant is always existing in between those two vectors. If this dotted line will be representing the resultant of P1 bar comma P2 bar, so that the P3 bar will be existing in this particular direction. The P3 bar will be existing in this direction, which is opposite to the resultant of P1 bar comma P2 bar respectively. P1 bar comma P2 bar respectively. Okay, you find the direction. How can you calculate its magnitude? Suppose we assume theta is the angle between the P1 bar comma P2 bar respectively. As you know the equation, P3 bar is equal to minus of P1 bar plus P2 bar. So to find the magnitude, what we have to do? We have to do the modulus on both sides. Therefore, the magnitude of P3 will be given by under root of P1 square plus P2 square plus 2 P1 P2 cos theta. Under root of P1 square plus P2 square plus 2 P1 P2 cos theta. Since minus is there within the modulus, it becomes to what? Plus. Here P1 bar plus P2 bar will be there. What is the P1 bar plus P2 bar? Vector addition. Whenever the two vectors will be added, the formula to calculate its magnitude will be given by under root of P1 square plus the P2 square plus 2 P1 P2 cos theta. It's a very, very important application whenever the bomb will be exploded into 3 different pieces. So this is the concept of explosion of the bomb. The next topic is explosion of a shell at the highest point of its parabolic trajectory. So before this, what we discuss about the explosion of the bomb. So where we consider that explosion is along the horizontal surface, along the horizontal plane. So there you discuss the bomb will be exploded into 2 different pieces or 3 different pieces. You discuss the law of conservation of momentum application there. So here also we are going to apply the same application, law of conservation of linear momentum. What is the meaning of law of conservation of linear momentum? Total initial momentum value is equal to total final momentum. If you took the explosion concept, total momentum before the explosion is equal to total final momentum after the explosion. So here initially we are assuming that a shell will be there and whose mass will be taken as, the mass of the shell will be taken as capital M. So I think a collision topic theory is completed to you. There you apply the law of conservation of linear momentum. So you apply the total initial momentum before the collision and after the collision. While you are calculating the linear momentum value, you took the velocity of the object, initial velocity of the object before the collision. So what is the initial velocity? Which velocity we treated as the initial velocity? The velocity of the object, what it have just before the collision, will be calling as initial velocity. Here also, what is the initial velocity of the shell we consider? Suppose we projected with initial velocity u, so we can't treat u as the initial velocity of the shell in the case of the explosion. So which velocity we consider? The explosion will be takes place at the highest point. So that before the explosion, what is the velocity of the shell? That is taken as initial velocity of the shell. So that before the explosion, the initial velocity of the shell is equal to u cos theta. So what velocity we consider here? Whatever the velocity was present just before the collision at the highest point, that only we have to take as initial velocity of the shell before the explosion. So you know the mass of the shell and you know the velocity of the shell just before the collision, so that initial momentum of the system is equal to what? M into u cos theta. In your material, in the place of capital M, they put M1 plus M2. Why? They assumed that the shell is explodes into two different pieces, so that P initial momentum is equal to, we will write M1 plus M2 into u cos theta. So I calculated the total initial momentum of the system before the explosion. And already we assumed that whenever the bomb will be explodes into 2 different pieces, they must be traveling in the opposite direction. So that after the explosion, these 2 pieces will be traveling in the opposite direction. Let it be V1 bar, let it be V2 bar. So whenever the 2 pieces are traveling in the opposite direction, their momentum values will be in opposite. So that the final momentum of the system is equal to M1 V1 bar minus M2 V2 bar. So the final momentum of the system is equal to what? M1 V1 bar minus M2 V2 bar. So actually this is the case 1. In the case 1, what we assume, the two pieces were traveling in opposite direction. So whenever the two pieces are traveling in the opposite direction, its the final momentum value is equal to what? m1 v1 bar minus m2 v2 bar. So according to the law of conservation of linear momentum, so what is the law of conservation of linear momentum? Total initial momentum of the system is equal to total of final momentum of the system. So what is the total initial momentum of the system? So the initial momentum of the system is equal to m1 plus m2 into u cos theta, m1 plus m2 into u cos theta, and final momentum value is equal to m1 v1 bar minus m2 v2 bar. So this is the case 1 what they given in our material. So this is the explosion of the shell at the highest point, and whenever the two pieces will be traveling in the opposite direction. Now see the case 2. Case 2. So in the case 1 what we assumed here, in the case 1 we assumed that the shell will be exploded into two fragments, and these two fragments will be traveling in opposite direction. Now in the case 2 what they mention is one of the fragment will be retraces its path. One of the fragment will be what? Retraces its path. What is the meaning of retraces? Retraces means what? That a piece will be traveling along the same path as the shell was traveled before the explosion. Once again, what is the meaning of the retraces? Means one of the fragment follows the same path as the shell was traveled, before the explosion. So that is the meaning of retraces. So here we assumed that out of the two pieces, one piece will be retracing its path, means that is following the path of the shell before it was exploded. If it is following the path of the shell, means it must be having the same velocity as that of the shell. Suppose before the explosion the shell will be moving in this direction. So one of the fragment, we are assuming the first fragment. The first fragment will be traveling in opposite direction. If the shell will be moving in this direction before the explosion, means what is the velocity of the shell before the explosion? The velocity of the shell before the explosion is equal to what? U cos theta into I cap. The velocity of the shell before the explosion is equal to what? U cos theta into I cap. If the first fragment will be traveling in the opposite direction, means the velocity of the first fragment is equal to minus u cos theta into I cap. Why I put the minus sign here? Since the first piece is traveling opposite to the direction of the motion of the shell, so that v1 bar is equal to what? Minus u cos theta into I cap. Once again, we apply the law of conservation of linear momentum. What is the law of conservation of linear momentum? Total initial momentum before the collision is equal to total final momentum after the collision. So total initial momentum before the collision is equal to what? m1 plus m2 into its a velocity value u cos theta into I cap. Now we have to write the momentum of the first piece as well as the momentum of the second piece. So the mass of the first piece is equal to m1 and its velocity is equal to minus u cos theta into I cap, so that its momentum is equal to minus m1 u cos theta into I cap plus m2 into, we don't know the direction of the v2. In this case, they will be traveling in the opposite direction. In this case, we don't know the direction of the v2. That's why simply we have to put m2 into v2 bar. So this is the case when a shell will be explodes and one of the fragment will be retraces its path. What is the meaning of the retracing? It is traveling along the same direction. While it is traveling along the same direction, in opposite direction, its velocity is equal to what? Minus u cos theta into I cap. So this is the case 2 in the case of the explosion at the highest point. Case 3. So in the case 3, we assumed that one of the fragment will be coming to the state of the rest. One of the fragment will be coming to the state of the rest. So the explosion actually takes place at the highest point, and it is explodes into two different fragments. Out of the two different fragments, so we assumed here one of the fragment will be coming to the state of the rest. So here we assume again the first fragment will be coming to the state of the rest. First fragment will be coming to the state of the rest. So whenever the first fragment will be coming to the state of the rest, its momentum is equal to 0. Its momentum is equal to what? 0. Once again we apply the law of conservation of linear momentum. So before the collision already we know the momentum value is equal to m1 plus m2 into u cos theta, m1 plus m2 into u cos theta into I cap, and the momentum of the first fragment is equal to 0. Why? It is assumed that it is coming to the state of the rest, so that its momentum value is equal to 0, and the second piece will be in the motion, so that its momentum will be given by m2 into v2 bar, Therefore, finally you got the equation m1 plus m2 into u cos theta into I cap is equal to m2 into v2 bar. So this is the case number 3. Case number 3 in the case of the explosion of the shell at the highest point.